Good evening and welcome to our second to last show of the school year. I'm Meredith Fish.
Hi everyone, thanks for being here. I'm Ryan Brett.
Students here in the Department of Meteorology have been hard at work lately, and we look forward to sharing some of their work with you this week.
That's right, students from our climate dynamics class will be here, plus we'll discuss how politics plays into weather forecasting and funding for NOAA.
But first, let's get started with the latest information from the weather, enterprise, and climate science community. Here's this week's Update in the Air. The Intergovernmental Panel on Climate Change says natural gas can be the bridge between carbon-heavy coal and zero-carbon renewables. However, it will only be effective if few gases escape during production and distribution. A study published on Monday showed that natural gas drilling could emit up to 1,000 times the methane previously thought, which would significantly increase its greenhouse gas footprint. Many studies agree that methane leakage is significant in many areas but question the overall impact. The study showed that during drilling, as much as 34 grams of methane per second were spewing into the air from 7 natural gas wells. The study concludes an urgent need to identify and plug methane leaks in shale gas production nationwide.
A recent study found that air pollution from Asia directly impacts the weather pattern and storm development over the Pacific Ocean. Researchers at the NASA U.S. Jet Propulsion Laboratory have hypothesized that these changes could be driving weather patterns here in North America. Given that jet stream patterns in the Pacific is a major driver of weather patterns globally, any changes could be linked to abnormal weather in the mid-latitudes of the Northern Hemisphere, including the U.S. and Canada. Urban centers of Asia are well known for high levels of smog and air pollution. In January, Beijing, China residents were urged to stay indoors after it was found that levels of particulate matter in their air were 18 times higher than those recommended by the World Health Organization. The researchers involved with this study are now saying that the air pollution in these cities is becoming more and more of a global problem. The added aerosols or particles are seeds for cloud formation. Typically, aerosol formation is thought of as the antithesis to warming, but this does not mean they are a good thing. An abnormal number of aerosols can fundamentally change cloud and storm patterns. The study suggests that aerosols from Asia are being transported to the Pacific region and may lead to changes in storm and weather patterns. It is far too premature to deem this a solid link in changing weather, but more research will be done to assess the global impact of Asian pollution. A topic that has been in the news lately is funding by the government for NOAA to improve its weather forecasting and computer modeling.
Students from Meteorology 482, our weather communications course, study what was being proposed by Congress to improve weather forecasting.
Now, this report by Eric Daunton and Ross Caruso was filed before the House passed the Weather Forecasting Improvement Act of 2014 a few weeks ago, but it's worth paying attention to now as it shows how politics can occasionally play a role in meteorology.
Recent severe events, such as Hurricane Sandy, have highlighted deficiencies in the current top U.S. weather model, known as the Global Forecast System, or GFS.
A House bill that would mandate the nation's top weather and climate agency shift its priorities more toward short-term weather forecasting has sped its way through the legislative process and is currently in the House.
The bill is aimed at changing how the National Oceanic and Atmospheric Administration, or NOAA, prioritizes its missions of weather, climate, and ocean science. Critics of the bill say that prioritization will shortchange long-term climate research in favor of improving forecasts of extreme weather.
It is sponsored by Representative Jim Bridenstine, a Republican from Oklahoma, who said the recent devastation of extreme weather in his state, including the tragic Moore tornadoes and a crippling drought, prompted him to push for better forecasting tools.
The bill that emerged from the subcommittee markup contains a provision that would require the NOAA administrator to make weather-related activities the top priority for planning in all NOAA line offices, including the Office of Atmospheric and Oceanic Research, which funds a large portfolio of the agency's research programs.
The House bill places an emphasis on short-term weather forecasting compared to climate. Bridenstine Press Secretary Cheryl Kaufman told Climate Central that the bill would prompt a shift in priority so that there is a higher priority on weather forecasting within NOAA when compared to climate research.
According to NOAA's definition, weather forecasts extend to 2 weeks in advance, while climate forecasts cover time spans beyond 2 weeks. Such climate forecasts include everything from seasonal drought outlooks, which are relied upon by water managers, wildfire, firefighting agencies, and farmers in particular, to long-range climate change projections that provide insight into how the planet is likely to respond to increasing amounts of man-made greenhouse gases.
The House bill also does not address the important role played by academia in advancing weather and climate knowledge. The bill's goal of improving weather research is laudable, but it needs to better reflect the reality that the majority of improvements in weather research come from our nation's research universities, said Scott Rader, Senior Advisor to the President at the University Corporation for Atmospheric Research, in a statement to Climate Central.
The bill directs expansion of NOAA weather research activities to improve weather-related technologies and develop highly accurate warnings of high-impact weather events, Oklahoma Commissioner Doak said.
In addition, H.R. 2413 contains provisions aimed at closing the performance gaps between NOAA's weather forecasting computer models and those of other nations, Doak's announcement said.
We were fortunate enough to get an interview with Dr. Titley, who is the director for the Center for Solutions to Weather and Climate Risk at Penn State. Here is what he had to say about the bill.
Comes across as a sense of frustration by the Congress towards NOAA. I think it really starts with credibility and with trust, and my assessment reading this bill is there's not a whole lot of that between the Congress and between NOAA right now. And that's what I'd work on. If I was NOAA, that's what I'd work at, trying to establish or restore, and then figure out what are the right kind of laws that we need to help the Weather Service move.
However, Congress has the final say in whether or not this bill will pass. For Up in the Air, I am Eric Daunton.
And I'm Ross Caruso.
Welcome back to Up in the Air.
Now, Meredith, it's that time in the program, and we take a brief look back at the weather and a look forward to our future weather in the Climate Outlook.
Yes, Dakota Smith is standing by with this week's Climate Outlook.
Thank you, Ryan and Meredith. And yes, finally, we're seeing some consistently nice weather across the Mid-Atlantic and Northeast, and that includes right here in State College, where we've seen 65-degree days and sunny skies consistently, which hasn't happened in quite some time. Unfortunately, the downfall to all this is the pollen and the allergies that comes with it. Might be able to tell I have a little bit of a sore throat and I'm a little stuffed up. But you know what? After this winter, I'll take it. I'll take the warm, take the allergies, as long as it's not cold. Before we get into the outlook, let's take a look at the radar-derived precip for the past day. We had this coastal system move through, impact northern Florida, parts of Georgia, the Carolinas, dumped quite a bit of precip out there. Then it went out to sea. And luckily it didn't impact the Northeast and Mid-Atlantic in our neck of the woods. Absolutely gorgeous weekend. Other than that storm down there, we saw a few little systems bring some showers to the center part of the United States, but the western half pretty much dry, and fortunately that went for us too in the Northeast and Mid-Atlantic. Dry weather, great weekend to get outside, as you guys know. Now this temperature map may look a little doomy and gloomy, but you know what? It says below normal conditions, but that doesn't mean it's not going to be nice outside. Just not as warm as we might expect it for this time of the year. The center of that below average conditions are going to be over in the upper Midwest, much below normal conditions for Wisconsin, Michigan, and that extends down into the deep south with western Texas, Louisiana, and southern Mississippi, much below conditions in terms of temperature for this time of the year. Again, if you're taking a trip to one of these places, don't worry about it. It's still going to be nice outside, just a little cooler than you'll expect for the middle of April. Out into the west, it's a different story, much above normal conditions, especially down here in Southern California and western Arizona. Going to be pretty hot out there. So if you're looking for hot weather, check out here. That extends all the way up into the Pacific Northwest with above normal conditions out there in terms of temperature. Now in terms of precipitation, the East Coast looks like it's going to get a little bit more wet than we've seen. We've seen a little dry spell after that cold front moved through last week, but we're going to see maybe a few more weather systems move through and put down a little bit more rain. We have a few spots out here in the center of the country where below normal conditions we'll see parts of Texas, and then up here in the upper Midwest with Minnesota and Wisconsin. Might be just a little drier than we usually expect for spring. Spring's a pretty active month, so we still may see some precip move through, but not as much as we see for spring. Now into the west, it's kind of a same old story we've seen in past up in the airs, below normal conditions out on the coast, but this time it extends out here into Nevada and Utah, below normal conditions for the west, as we've seen over the past few up in the airs. I hope that gave you a little bit of taste of what to expect in the next 8 to 14 days. Ryan and Meredith, I'll send it back to you.
Thanks very much. And now switching gears to our weekly report from Penn State's climate dynamics students.
The hurricane season is fast approaching. It begins June 1st and ends November 30th. Many factors come together in producing such violent storms.
Now Tom Gowan and Andrew Thomas are here with details and a look specifically at how Saharan dust can impact hurricane development.
Hi, this is Tom Gowan alongside Andrew Thomas, and we are here to talk about how dust from the Saharan Desert in Africa affects the Atlantic hurricane season. Saharan dust is composed of tiny aerosols like sand, dirt, and dust. During the Atlantic hurricane season, this Saharan dust can be picked up by African easterly waves and transported from east to west out over the Atlantic Ocean. One of the main effects of the Saharan air layer is a reduction in the number of hurricanes that form over the Atlantic Ocean. The dust present in the Saharan air layer is extremely detrimental to the development of hurricanes. Andrew will now take over and explain why this is the case.
What causes the Saharan dust to be pulled up from the surface and into the mid-levels of the atmosphere? Like Tom said, African easterly waves pick up the dust, lift it up into the atmosphere, and out over the ocean, just west of the Sahara Desert. This region just happens to be one of the major breeding grounds for hurricanes in the Atlantic Basin. Here, the hurricanes start as a cluster of thunderstorms known as a tropical disturbance. To understand how the dust affects hurricane development, we first need to understand what causes thunderstorms to strengthen. Basically, thunderstorms are strengthened when warm, moist air from the surface rises up to the top of thunderstorms. Once this warm, moist air hits the layer of dust, it dries out and becomes cooler than the background environment. This causes the air to sink back down, limiting any strong thunderstorm development. Along with limiting updraft in thunderstorms, Saharan dust also affects how much the sun can heat the ocean. Normally, the sun has a clear shot to the ocean, causing it to get very warm rather quickly. The warm water then leads to instability and clouds. These clouds then strengthen into thunderstorms and eventually into tropical disturbances. With a large layer of Saharan dust in the mid-atmosphere, the sun is unable to warm the ocean waters as much as it normally would. With cooler ocean water, there is less heat available for updraft, which is necessary for thunderstorm development. Without the development of strong clusters of thunderstorms, it is impossible for hurricanes to form.
On this animation, you can see the dust, which is colored in red, being swept off the Saharan Desert during the summer of 2013. The extent of the Saharan air layer can be huge. As you can see in this time-lapse animation, the layer of dust extends thousands of miles from the Saharan Desert all the way into the Caribbean and northern South America. This massive Saharan air layer that we experienced during the 2013 Atlantic hurricane season is one of the reasons why there were so few hurricanes. Basically, if you don't want hurricanes, Saharan dust over the Atlantic Ocean is good. It prevents the development of hurricanes in two ways. One, by preventing warm air from rising through the mid-levels of the atmosphere, and two, by limiting the amount of solar radiation from the sun that can heat the ocean. For Up in the Air, I am Tom Gowan.
And that's going to do it for tonight's episode, the second to last of the school year.
Wow, can you believe it?
No, I really cannot. Thanks for joining us. I'm Meredith Fish.
And I'm Ryan Breton. We hope you enjoyed this week's show full of content from students right here at Penn State. Join us next week for the final time this school year, Up in the Air.